Okay, welcome, Michael and Austin and Ivan and Courtney and Lydia and Anna. Thanks for showing up. And it's a little smaller group than usual. I did get a couple emails that a couple can't make it for personal reasons. I won't get into it, but let's get on to talk about the quiz. So let me share screen. And here's the quiz. And this quiz just had one question, although there were three parts of the question. So it's really kind of three questions wrapped in one. And it was the average age of first marriage is 28 years old. Okay. I looked that up. Google told me so it must be true. And then suppose that the standard deviation is 5 years. That I totally made up. For each, find the distribution, then answer the question, then determine if the assumption that the distribution of the population is normal was necessary for your calculations. Okay, and there's a 1, 2, and a 3. The first is find the probability that a randomly selected American will first marry before the person turns 21 years old. All right, the first thing I'm going to do is I'm going to note that the average age was 28, standard deviation is 5, and we're going to just for now assume it's normal, and then we'll talk about if we had to. So let's see, I think I have to hit preview. There we go. So the first thing I like to do is I'll write X. So let's write number 1. Okay, so now notice a keyword here. And it's something I mentioned in the webinar on Tuesday too. It's the smallest word in the whole sentence on question number 1. And what is it? A. Okay, so notice that we're only talking about a randomly selected American. We're not talking about a sample. We just have a single individual. So that means it's an X, not an X bar, or anything funny that we'll be doing later today. So what we can say is that X, oh, let me remember the numbers, 28 and 5. So we can say X tilde N 28, 5. So that's the first part of number 1. Okay, and what we're asked to do is find the probability the person marries before they turn 21 years old. So that's probability that X is less than 21. Any questions on that? Okay, so now what we need to do is use the calculator. So what number am I need to go to? Number 7. So I hit normal probability. What is the low? Yeah, the low is negative 9999. Oops, 9999. If you put 0, actually, you'll get the same answer. Actually, I purposely made it that way so I didn't have to like think twice as I'm grading it, because 0 is so many standard deviations below. But just technically, since it's a normal distribution, it's better to have negative a bunch of 9s. How about the high? What's the high on this one?
21.
Yep, 21, because we want the probability that they marry less than 21 years old. Okay. And the mean was given as 28, I believe. And the standard deviation was 5. Any questions on that so far? Okay, and I hit calculate. And there we have it. About 0.08. Okay, if you want to go more decimals, you can. Probably nobody cares about more than 2 decimals because that gives you a nice percent. It's pretty close to exactly 0.08 anyway. So what we can say is that the probability, that one, that this probability that x is less than 21 is equal to 0.08, about 8% chance. Okay, and by the way, if you're not sure if you got it perfect, you can always put in a little sentence of what you did so I can give you partial credit. So I went to the normal calculation, normal calculator. With a low of negative a bunch of 9s, a high of 21, a mean of 28, and a standard deviation of 5. So can't hurt to write down your work because that way I can find ways to give you points if you got it wrong. Okay, then you read the question. I'm supposed to determine if if the assumption that the distribution of the population is normal was necessary for your calculations. Okay, here we did these calculations. I used the normal distribution. Do I need to assume that we have a normal probability and a normal distribution? Or do I just know it for sure? Was the assumption necessary? What do you think?
There's a little guy.
So this is where, oh, can anyone hear me?
Yep.
Yeah.
Okay. I was a little confused because essentially the sample size is only 1, which is less than 30.
Exactly.
Okay, that's the way to do it.
Yeah, you can start saying but and stuff. No, what you said was perfect. Okay. You can either say the sample size was 1, which is less than 30, or we're not doing a sample, we're just asking 1. So since only a single individual is looked at, the central limit theorem doesn't apply. And the normality assumption
Thank you, little buddy.
was necessary. Any questions on part 1?
So do we have to say both of those, that the central limit theorem doesn't apply and the normality assumption was necessary?
Yeah, so the reasoning behind it is that the central limit theorem doesn't apply. And will I take off points? No. But if this is kind of the way you're thinking about it, then you're going to get it right every time. Does that make sense?
Yeah.
So that's why I do it. Do you have to type all that out? No, but should it be in your brain? Yes. Does that make sense?
Yes.
Okay. I'm a teacher, so I'm going to type it all out so that I can force it to hopefully be in your brain. Does that make sense?
Yeah, that makes sense.
Because that's my job. So again, sometimes I'll give more than you necessarily need. But again, it can't hurt to type all that out as long as you have enough time. Okay, let's look at number 2. So number 2 is if 6 randomly selected Americans are surveyed, what's the probability that their average age of first marriage will be between 26 and 29 years old? Okay, that changes things. Now we have a sample size of 6. Okay, so it's not going to be x tilde n 28.5. What changes? What changes? Yeah, the first thing is it's not x anymore, it's x bar. And again, it's easy to just write x bar. You could do a fancy, formula stuff, but on a quiz, just do x bar, it's easier. Okay, and then tilde. Still have n. Do we still have 28? Yes. But I want to give you a warning. There's a very important warning. Yes, we still have 28, but that will not be true for everything we do after this quiz today. Okay, so that's just a note, is that the next thing that we're doing when we're doing sums, that number is going to change. And I have found it is the #1 mistake I see on the next main exam and the final exam is when I give a sum problem is they don't change that number. So I want to give you a warning, even though you don't even understand why I'm warning you now, but trust me, you always want to be thinking about it. So since we're looking at means, mu sub x bar is mu. Okay, does the 5 change? Does the 5 change, or does the 5 stay the same? What do you think? Okay. Okay, the answer to the 5 changes. Because now we're talking about a sample size of 6, and we're taking an average. And when you're taking an average, sigma sub x bar is not sigma. Sigma sub x bar is sigma divided by the square root of the sample size. Do you remember that? So we're actually going to be looking at not 5, but 5 divided by, I'll just write SQRT, 6. And just so I get that number, I'm going to pop that into my Google calculator. And it's about 2.0412. So that's N 28, comma 2.0412. Let me double check. 2.0412, yeah. Any questions on that? Okay, very important that you make that adjustment. Changes everything if you don't. Okay, so now let's find the probability that, and again, let's read the question again. When the probability that it's between 26 and 29. So that's going to be 26 less than x less than 29. Write that down because I'm going to leave the screen so I can get to the calculator. So 28, 2.0412, and 26 to 29. And now I can go into my calculator. My low is 26. My high is 29. The mean is still 28, but the standard deviation now is 2.0412. And I need to erase my p. And I get about 52%. 0.52 is good enough for me. Just a warning on the online homework, if it tells you 4 decimals, do 4 decimals, not 2. Okay, on the quizzes, I don't care. As long as you show your work, I'm happy. Okay. And maybe I'll just put in, I went to the normal calculator with a low of 26, a high of 29, a mean of 28, and a standard deviation of 2.0412. Okay, now we need to decide whether the normal assumption was necessary. And what do you think? Was the normality assumption necessary? Okay, and the answer is yes. How come? Because the reason is actually different here. Yeah, we have a sample size of 6. So since n equals 6, which is less than 31, the normality assumption was necessary. Any questions on number 2? Okay, let's go to number 3. So for number 3, it said there's a 95% chance that 34 randomly selected Americans will on average have their first marriage past what age? Okay, so now let's start out with the distribution. So is it X or is it X bar or something else? Yeah, this one's X bar. This one's X bar because we're talking about average. So tilde n, still 28. What's the standard deviation this time? How do we get the standard deviation for this? Yeah, 5 over square root of 30. I think it was 34 though, isn't it? I do the same thing as I'll often forget the number, but it was 34. Okay. So that's what we have. And that's equal to n 28, comma, and let's do 5 over square root of 34 in a calculator. And I get 0.85749. Any questions at all on the distribution? Okay, so now I'm gonna need to find, I'm not looking for a probability this time. What am I looking for? So let me remind you what the question was. Now there's a 95% chance that 34 randomly selected Americans will on average have their first marriage past what age? Yeah, so now I'm looking for the high, okay? Actually, I'm looking for not the high, I'm looking for the low, right? Because it's past what age? So I'm looking for the low. So what we know, let's write this out. Is that the probability that X is greater than, I'm gonna write question mark because that's what we don't know, is equal to 0.95. Any questions on that? So we want the low, not the high. So let's go find it. So now we go to our calculator. We don't know the low, so that's what I'm going to leave blank. What's the high? Yeah, a bunch of 9s. All right, you got married at when you were 9,999 years old. Good enough for me. 28 was our mean. Standard deviation was 0.85749. And the P is 0.95. Because that's what we're given. And then I click calculate. And it's about 26.6. Good enough. Okay. So a little more than 26 and a half years old. So 26.6. So the age when 95% have already been married is 26.6 years old. Was the normality assumption necessary? Yeah, no, how come? Yeah, we have 34. So n now is equal to 34. N is equal to 34, which is greater than 30. So the central limit theorem guarantees that the sampling distribution is normal. So the assumption was not necessary. Any questions? Any questions on this?
Yeah, quick question. I'm just trying to figure out how 26 would be like 95% when that's less than the mean.
Right, so 90, so it's less than the mean. So if I told you what age, let me double check this. Maybe I did it wrong. So let me double check because I'm just looking at, let me read the wording. There's a 95% chance that 34 randomly selected Americans will on average have their first marriage past what age? So the idea here, yeah, it is right. So the idea here is, for example, let me just give you an easier one. What do you think the chance is that that people who are married got married past the time they were 2 years old?
Past 2 would be 100%.
Exactly, exactly. What do you think the percent if it was past 28 years old?
50.
Right. So 95% is somewhere in between 2 and 28 years old. Is that clear?
That makes sense.
Yeah. So we expect it to be young. Okay. Younger than 28 years old. Is that clear?
That makes sense.
Okay. The age turned out to be 26.6. Now that seems pretty close to 28, but remember, we're not talking about one person. We're talking about the average of 34 people.
Yeah.
And the averages tend to be really close to the population mean. Is that clear?
Yeah.
Yeah. So that totally makes sense?
Yeah, thank you.
It was feeling like it should be older, right? Like over 28. And if you think about it for a while, then it does make sense. So I'm going to ask you to guess on something. Guess a probability. What do you think the probability is that on your exam, you're going to have a question that has these instructions?
100%.
Exactly. Okay. Make a note of that. Okay. Practice these. Get good at them. Okay. So you need to be able to find the distribution, answer the question, and determine if the assumption that the distribution of the population is normal was necessary for your calculation. I guarantee it will be on your exam, and not only that, I guarantee it'll be in your final exam too. It's that important. Got it? Okay, it won't be about age of first marriage. Okay, it'll be whatever else I make up. But that's not the hard part. The hard part is to understand the processes at which you need to answer these questions. And what I try to do is I try to make sure the exams look very much like the quizzes. Did you notice that for the first exam? Did it feel like it looked like your quizzes, other than it was longer? Yeah, and that's going to be true of the second exam. It'll be true of the final too. So just beware that the quizzes are your best tool for understanding and predicting what the exam is going to be like. Okay. Okay. The only thing I add on the exams are true or false, and that's just kind of my signature. So they'll always be true or false on the exams. Any questions at all on this quiz? Okay, now I'm going to go to something that to me has been very important in life. And again, I don't know where you are in life, but it could become important for you too. And if you do it wisely, it'll make a big difference in your life. So let me pop a website and then you'll hopefully know what I'm about to talk about. Any guess on what I'm talking about? Recognize that? Yeah, stocks. So I will let you know in terms of my own personal experience is that I use statistics when I invest. Okay, I use statistics. I use more than what you're going to learn in this class, but I do use some of what you're learning in this class. And it depends on how I want to invest in terms of the statistics I'm going to be doing. Okay, so I know you probably don't have $100,000 to spend or whatever. You actually don't even need that much. $1,000 is enough. Okay. Tell us what level day today has. Tell us what level day today has been. I don't quite understand what you're asking. I mean, we're in terms of the market right here. The Dow Jones is up 211 points. So it's been a good day for the market. Okay, but what I want to do is I want to relate this to statistics. We're going to make some assumptions, okay, and they're big assumptions. How much money? I actually did not invest today. I don't invest every day, but I do invest some days. I'm waiting a little while. I'll let you know that. I think it's going to dip, and then I'm going to put money back in. I think we're on the high side right now, so I'm on the waiting mode. Okay, but have I made money? Any guess? Do you think I've made money on this whole coronavirus thing?
Yes.
Yeah. Not too much, about $10,000. But hey, I'll take it. Takes me 10 minutes to do that. Not bad, right? So I've learned how to make money on issues. When there's big things going on in society, I figured out how to make money. So let you know, but you got to study this stuff. All right, so what I want to do is I want to focus on a couple things. I want to give you two situations, okay? And they're personal, historical personal. So I don't know if I've told you, but I have a daughter, and she is older already. She's out of college, she's finished, which means I'm done in terms of paying for it. So when she was young, I needed to put her money, I needed to put money because I wanted to afford her, I wanted to pay for her education. To me, that was important. So I needed to put money into an investment so that I was rest assured that that money would stay stable enough so that I didn't feel guilty if something bad happens and then I told her, I'm sorry, you have to pay for your own college. I didn't want to do that. So what I did is I invested in what's called an index fund. Have you heard of that before? Okay, I'm not going to get involved in the details of my index fund. I'm just going to use the easiest one that we all understand, or you've all heard of. I don't know about understand, because it's easier to talk about instead. And I'm going to explain why I did that. Okay, so let's suppose we invested in what's called the Dow Jones Index Fund. Okay, but I also invest in other things. So I have two different kinds of investment strategies. One is the strategy. There's two cases. One is for my daughter and the other is for my retirement. Two places where you don't want to end up in bad shape. Okay, hopefully y'all agree with that. But then I also have what I call my play money. And that is when I want to invest and I want to make a huge amount of money as a possibility. But I might lose money. Does that make sense? So I'm going to start out with a play money because that's easy. And play money, by the way, it's real money. I put it in. Last week I just sold $15,000 worth of play money. Okay, so it's not like just playing a game. It's real. But I didn't have to like tell my daughter that she can't go to college or something like that if something happens. So I'm going to mention a couple things. One is over the years, the stock market averages around 9% per year in increase. Okay. So it averages about 9% per year of increases. Okay. The standard deviation is around 20%. Okay. It goes up and down a lot. So here's the question. If I invest for just 1 year, okay, and we'll keep it 1 year because it makes it a little easier. If I invest for 1 year, then what is the probability I'm going to lose money is the question. Okay, so let me write down a few things. So the first thing is, if we're just going to invest in one stock, am I going to use X or X bar? Yeah, this one's an X. So this is X tilde N, okay? And that is going to be X tilde N. And then I told you the mean was 9%. You could use 0.09 if you want. As long as you're consistent on your units, you can do whatever you want and understand what it means at the end. So X tilde N, 9, comma, 20. So that means the mean is 9 and the standard deviation is 20. And I want the probability that I'm going to lose money. What does it mean if I'm losing money? What does it mean? Y'all know it in like ideas, but what does it mean in terms of inside that P of? What do I write? Any thoughts? As soon as I say it, it's going to be really obvious to you. Lesson 1? Well, you know, if I make 0.5%, I made money, didn't I, Austin? So if I lose money, what does that mean? Yeah, less than 0. Probability that X is less than 0. So remember, this is a continuous distribution. So don't just go up 1. It's less than 0 is losing money. Is that clear? Okay, this is very easy to calculate. We can pop this into the calculator. So what we can say is that the mean was 9, the standard deviation was 20. And the high, that was my 0. What's the low? Yeah, negative 99999. That better not happen, or I go bankrupt, but it won't. It never has. Okay, and hey, calculate. And that is about 33%. Any questions on that? Okay, so that's a 33% chance. And I'll write it as a percent because it's easier to understand. All right, is that something you think I was willing to risk when it comes to my daughter's education? No, I couldn't live with myself if I had to tell my daughter, oh, sorry, I played with the money and I lost it all, and sorry, you know, you're on your own for college. I wouldn't do that. Is that clear? Okay. So let me tell you index fund idea. So let's go back. And I'm going to make an assumption, which isn't true, but I'm going to make an assumption. It is true for the index fund I actually invested in, but I'm going to make the assumption on the Dow Jones, and that is I'm going to assume that the stocks are independent of each other. Okay, not true, but we're going to make that assumption. Okay, so the stocks are independent of each other. Okay, now they're not. If you want independent stocks, do you know what the word for that in finances are? You know what the word for that? You've probably heard this word. What kind of investment is it? Yeah, a diverse portfolio, exactly. So when they say you should have a diversified portfolio, the reason is if you have a diversified portfolio, then the central limit theorem applies. Okay, and you may have never heard that before, but that's the truth. If you do not have a diversified portfolio, then you might as well just have one stock. If all of your, if you buy, let's say you buy in United Airlines and Southwest Airlines and American Airlines, that's not three different stocks really. Okay, that's just airline companies. So, but if you get a diversified portfolio, and that would mean multinational stocks, gold, real estate, all kinds of different things, and you can do stock in that, by the way, then it's pretty independent. It's not perfect, but it's pretty independent. And then the central limit theorem applies. So I'm going to make that assumption even though it's not true. So let me ask you something. This is an economics question, not a math question. Who knows how many stocks are in the Dow Jones? Anyone know? Getting all kinds of big numbers. No, let me show you. Could always go to Google. 30. So the Dow Jones is 30, and they're 30 big companies, by the way. Okay, I'm not going to show you all the companies, but you can go look them up and find out. There's 30 companies. So now that changes everything. So now let's suppose we're going to pretend that it's a diversified portfolio of stocks. We're going to do an index fund, but now it's not X anymore. What is it? Yeah, it's X bar. Okay, so now it's X bar tilde, and it's still going to be N. Okay, and now the mean is still going to be 9 because that doesn't change with the central limit theorem. But what about the standard deviation? Does that change? Yeah, that's going to be 20 over the square root of 30. And that's normal 9 comma. And now let's get the square root of 20 over the square root of 30. Just pop that in. And that's 3.6515. And let me close the parentheses. So I'm going to stop. Anybody lost? Anybody lost on what just happened? Okay, I still want to find out what's the probability of losing money. So what is the probability that X bar now is less than 0? Same idea. And to do that, I do exactly what I did before, but now my standard deviation is 3.6515. So I can go back to my calculator, and the standard deviation changed a lot. Okay, we still have the same low, same high, same mean, standard deviation new, and we got to erase the probability. And I hit calculate. Any guess on how things are going to change? We had about 30-something% chance of losing money before. Okay, let's take a look. 0.006855, et cetera, et cetera. Okay, or about 0.007. All right. Do you think this is a better investment if I'm worried about losing money, if losing money is horrible? Yeah, this is much better. This is much better for investments where you really don't want your money to go down. Okay, it'll be a bad thing in your life. Okay, instead of just a bad day, it actually is a bad life experience. Is that clear? Okay. I do want to let you know, though, let me ask you, is it ever better to go for the single stock? What do you think? Okay. Don't get money to lose, but even more if gaining is really important. Okay. All right. If it is just going to make me like just feel so good because I just made 15%, then I'm going to go for the single stock. Okay. I might lose, but hey, I can make money. Okay. So I can make big money. So it turns out that sometimes this is better. And the other reason why this is better, and this is not it's not elementary statistics. The other reason why this is better is that if you really understand investments, then you can find stocks that are going to have an average return much higher than the 9%. And I will let you know that takes research. Okay, that takes a lot of work that has a little bit of math involved. It does have some math, but it has a lot of understanding society. Okay, and then you can actually get a higher than a 9%. Whereas if you're trying to do something based on general stuff, you only get that 9%, especially over time. So that's just a note for investment strategies. Okay, and by the way, I will let you know from my experience, I have made a lot of money, okay? Not billions, but a lot. I was able to buy a house in cash from the stock market, okay? Just to give you an idea of how the stock market is done for me. And that's because I look at it mathematically, okay? And through society. And that's the important thing is if you do the statistics, you can make good money, but you must do the statistics first. Otherwise, it's not going to go well for you. Okay, then just pay someone else to do it for you or something. Any questions on this example? Okay, I like this one because, like I said, it's meaningful for me. In fact, I got a present when I was a teenager of some stock, not a huge amount, but it got me into it. So it was kind of a nice thing to do to a kid. And then I got into it, I researched it, and now I've known forever. Okay, so disabled, I'm able to do it. Okay. Unfortunately, I'm not allowed to teach a stock market class because that's a business class and my degree is not in business. So I'm only allowed to teach math classes. So sorry, I can use stock in my math class as an example, but I'm not allowed to. Okay, any questions at all on this example? It's an important example. Okay, so let me do one more question. Okay, let's suppose we want the following. Suppose you want to have a portfolio such that the standard deviation is instead of the 20, let's suppose we wanted the standard deviation to be 1. How many stocks should be in their portfolio? And I'm going to write diversified, so we're going to assume they're independent. Any questions on the question? Any questions? Any idea on how we go about answering this question? Any thoughts? Okay, if I don't see an answer, let me show you how you do this. The first thing is we start out with the standard deviation formula for the central limit theorem. And that, if you remember, was sigma sub x bar is equal to the fraction sigma divided by the square root of n. Do you remember having that formula? And let's make it big so you can see it better. Any questions so far? Okay, so now what we want to do is we're going to plug in everything we know. So let's plug in what we know. So do we know sigma sub x bar? What do you think? Do we know sigma sub x bar? One more guess? Do we know sigma sub x bar? The answer is yes, it's 1. Because we want the standard deviation for the portfolio, that's the sigma sub x bar, to be 1. So 1 is our sigma sub x bar. Is that clear or is that confusing? Okay. All right, so we want our portfolio to have a standard deviation of 1. The portfolio standard deviation is the standard deviation of the average of our portfolio stocks. The standard deviation of the average is sigma sub x bar. That's what that symbol means. X bar is average. The standard deviation of the average portfolio. Do you see that? Of the average of our portfolio. Do we know sigma? Do we know sigma? Yeah, sigma is 20. That's given. Over the square root. Do we know n? No, that's what we want to find out. So that stays as n. I do want to remind you this is a math class. So yes, you are responsible for doing a little bit of basic math, not too intense. But I need to solve for n. And if you have a fraction equals 1, you can multiply both sides by root n. Okay. So let's go to an equation. And we can say the square root of n equals 20. So how do I get n? I'm hoping you all know how to do this now. Not square root of 20. Yeah, it's 20 squared. We square both sides. So n equals 20 squared. I'll do it this way. And that's 400. Any questions on that? So if we have a diversified investment of 400 stocks, then our standard deviation should be 1. The hard part is getting it to be truly diversified, by the way. That's actually really tough. Okay, just note, the S&P 500 index fund. Do you think that's going to have a standard deviation greater than 1 or less than 1 if it's a diversified portfolio? Yeah, that one's going to have, one more guess. Notice the hint is 500 is bigger than 400. And a bigger sample size gives you a smaller standard error because you're dividing by root n. So if we invest in the S&P 500, and I think it might be obvious that there's 500 stocks in the S&P 500 index fund, then instead of dividing by root 400, you can divide by root 500, and you can get a number smaller than 1. Okay, and again, that's a big assumption that it's diversified. So I want to clarify that we're assuming. Any questions on that? Okay, so now let's go to the central limit theorem for sums. Okay, so let me give you, it's another financial example. They work well in this stuff. And let's suppose that you own a business, okay? And let's see. All right, let's suppose you own a bike shop, because I have just heard Friday, that's tomorrow, they're gonna allow bike shops to start being open again. And I don't know if you heard that. I don't know if it's really true, but that's what I heard, is that that's gonna be one of those businesses that are supposed to open up. Okay, one of the first ones. So suppose you own a bike shop. Okay. What do you care? Do you care about the average amount of money people spend at your bike shop? Is that the most important thing at the end of the day? Okay, the mean is the average, by the way. Yeah, you care about your profit, but in particular, if you're looking at people, you care about your revenue, not the median. You care about your total revenue or your total profit. And that's not the average, that's the total. Okay. So if you have 100 people walking into the store and spending, 20 bucks each, guess what? At the end of the day, you've made $2,000, and that's all you care about. The average of 20 is much less important than the total of 2,000. I know there's a formula for one or the other, but in terms of the way you want to think about it, it's the total amount that you care about when you're talking about being a shop owner. Is that clear? Okay, so there are cases where total is more important than average. And sum is another word for total, by the way. So typically it's called central limit theorem for sums, but you can also call it central limit theorem for totals. So look for either of those words, sum or total, in a word problem. Okay, and it says the same, it says something real similar to the central limit theorem for means. And it says the following: the sampling distribution has mean. Let me do the following and make that bold space so we can see that, and actually I'll make it red. You can really see this is what we're talking about right now. So the sampling distribution has mean. Remember, this is the mean of all possible totals. Sounds weird. It's not the average amount people spend in the store. It's the average daily revenue you might have over many days. So it's an average total. Is that clear? Okay, so the first thing, and this is, you're gonna have to bring, bring back your brain and see if you can remember. If you're adding, if you're doing a sum, what symbol do we use for a sum of a bunch of things? Do you know? Yeah, you're close. Big E, it's actually capital sigma. But I'll accept your big E because it does look like a big E. It's that guy. That's what you meant, right? Yeah. So that's called I'm going to specifically say capital sigma because lowercase sigma we use for standard deviation. A little confusing. Don't shoot the messenger. This is just what all mathematicians use. Is that sigma, okay, capital sigma is equal to, actually, I guess I should say, let me go, not capital sigma, let me go mu sub capital sigma, because it's the mean of all possible sigmas. There it is. And what we want to do is we want to find out what that's equal to. Well, if I told you what the mean was, mu, and you wanted the total, what would you do? So if I said I had 100 people walking into the store, into the bike shop, they each spent an average of 20 bucks. How do you find out how much money you made? How much revenue you had? It's very easy, by the way. Yeah, you multiply. You take the average times the sample size. Okay? So it's the average times the sample size. And the average is mu. And the sample size is n. Okay, any questions on that? Okay, now I have a harder math question, which I expect a lot of you can't do, but that's okay, you don't have to. But some of you might be able to tell me. Same thing, if the standard deviation is multiplied by n, it's the same idea. If you take sigma over root n times n, what does that become? So again, this is going to be a sigma sub capital sigma. So it's a standard deviation of all possible totals. And a little algebra. If you take sigma over root n and multiply by n, how does that simplify? Calculus you probably know, I hope. All right, if you don't want to tell me, I'll tell you. That's going to be sigma times the square root of n. Again, I'm not going to require you to do the algebra to prove that's true. I am going to require you to just have it on a note sheet and know when to use it. Got it? Okay. So sampling distribution, let me write for sums. And I'll even put parentheses totals. And that's the big theorem. Any questions at all on this theorem? I gotta get some water. Okay, so let's use it. Okay, suppose that the average amount of money spent in a bike shop is, let's say, 40 bucks. And the standard deviation is, how about $21. Okay, it's gonna be a pretty big standard deviation. Some people are gonna buy the bike, right? Okay. Suppose that on a typical day, $200 people come into the bike shop. Okay. By the way, why is today definitely not a typical day? Yeah, you're not allowed to have a bike shop open today, but tomorrow I heard that you could have a bike shop open. In fact, I need to fix my brakes, and I hope I can find someone to do it for me. So I'm going to be going to a bike shop pretty soon. Okay, so suppose on a typical day, 200 people come into the bike shop. Okay, find the probability that the total amount of revenue for the shop is less, let's go greater than, let's be positive, than, where are we? 75 $100. Any questions on the question? Any questions? Okay, I'm just looking. I don't have too many people in today. We have what, 3 to 4. It's just 5 of you here. So maybe I'll put you into 2 groups because I want you to work on this. I want you to try doing one of these. So why don't you write down, I'll put in the chat box too, because I never know. Oops. I never know what you can see once I put you into groups. Yeah, so now it's in the chat box. You could copy and paste it onto your computer so you've got it because you may lose it in a minute. And I am going to see if you guys can work together on this. Let me go breakout rooms, and I'm just going to go 2 rooms. And let's see if you can work this stuff out. Did you guys talk about the normality assumption?
No.
Because that was that's a piece. Remember, I told you that's always going to be asked.
What? Oh, we have 200 people. So that's more than 30. So it's not needed.
Good, good. I'm going to close rooms. Oh, takes a minute. The other group's a little slower than you guys, so they're still working. Okay, let's get back and let me share the screen and let's see how y'all did. Okay, so you can chime in. The first thing is, what's the key word? What's the key word that will help us decide what the first letter is in the distribution? Yeah, in this case, it's actually sum is not in this question. So yeah, total, I'll go for that, total. Yeah, so this one, so the key word here is total. Always look for that word. Okay, again, I would say 75% of the people get it wrong on an exam when I give a question like this. And the reason they get it wrong just about always is they don't look for that keyword. And they just, they don't multiply by n or root n and all that. They just ignore it. And that's bad, by the way. You lose a lot of points if you do that. So don't make that mistake. Okay, so because of that, what we can do, and I'm just going to copy and paste the formula and then just plug in. So mu sub sigma, what was mu? That's given. What number was mu? Yeah, mu sub sigma was 40 times, and what was n? 200. Okay, and then we have this standard deviation of the total, or sigma sub capital sigma. What was lowercase sigma? What's the standard deviation? That's 21 times the square root, and n was 200. Any questions on that? Let's, there we go. Okay, so there we go. Now what we could say is that our sigma, or mu sub sigma, actually the mean total, or sigma actually, so let me go insert equation. Let's go to sigma tilde N, and then 40 times 200 is 8,000. That one I can do in my head. The next one's a little harder to do in my head. What do you get if you take 20 times the square root of 200? Maybe you could pop that in the chat box. What's 20 times the square root, 21 times the square root of 200? What do you get? Yeah, 282.8427. And there's our distribution. We want the probability that the revenue is greater than 7,500. So we want probability that sigma is greater than 7,500. Any questions on that? Okay, and you can pop this into the calculator. I'm going to assume that you did it. If you got these numbers, I'm going to assume you did it right. What do you get? Oh, okay. We got someone that said they have a different standard deviation, 21 root 200. Let me double check. $296.9848. So it's a little off. It's not one I can do in my head. That's why I was trusting you. But I definitely trust Google. Google never gets it wrong. Okay. So now let's put in the numbers. 8,296.9848. That's the one I gotta not, I don't have memorized. And 7,500. That was that one. $7,500. Our high is millions. And then our mean again was 8,000. That one. Our standard deviation was that messy number. We want the probability. And it's about 0.9539. Any questions at all on this example? Any questions? Okay, so we can see now. So we can see now that there are different types of central limit theorem. Now there's a third type. So now let's talk about another central limit theorem example. Not example, a theorem. Central limit theorem for proportions. Okay, proportions. There we go. Okay, so now imagine having a survey question. In fact, I have an example. This I can take out of the news. This one you're not going to make any money on, but I don't know, you might be interested in. By the way, what's coming up in, I don't know if it's from today, in a half a year from now, might have been yesterday. A lot of people have forgotten about it. Yeah, the election. Okay. So what's coming up is the election. So let's take a look at Trump's approval rating. Okay. And This is a Gallup poll. So Gallup is one of the kind of the main pollster groups. And what Gallup did is they surveyed and they asked a lot of people, okay? And they said, and they asked, you know, do you approve of the job Trump is doing? And 49% of the people who responded said, yes, I approve of Trump's job. Okay, how Trump's been doing the job as president. 49%. Okay, and yes, it goes up and down, but we're just going to go for now. And 49%. This was a little frustrating. I was not able to find their sample size, and I actually think it's because with this whole coronavirus thing, my guess is they're understaffed. So I think that they're not making the website as much information as they used to. So sorry about this. First time ever I've not been able to find a sample size on Gallup on this thing. But I'm going to tell you just from my experience, their sample sizes are usually around 1,000. Okay, Gallup tends to survey 1,000 people, not always, but I'm gonna assume that they have surveyed 1,000 people. So can I ask you, does the majority of Americans, of all Americans, approve of Trump's job? Approve of the job Trump's doing? What can you say? Let's see if you can all chime in. Does the majority, okay, of all Americans approve of how Trump has been doing his job? Okay. Okay. The answer is we don't know. Okay. We don't know because this 49% is not all Americans. Okay. I know for sure it's not all Americans because they didn't ask me. I'm an American, by the way. Did they ask any of you? Okay, I've never had any. I ask this every single time I teach stats. I've never had anyone say, yeah, they asked me. Okay, chance of, you know, asking someone is really small when you got 330 million people or something in the country. So, and if you're not American, sorry, they didn't ask you either. Okay, or maybe they probably asked American adults. So they didn't ask. So here's the question. We don't know if the majority of Americans approve of the job Trump's doing, but here's what we can do. And let's go back to a question I have for you. What is the probability that the majority of Americans approve of the job? Okay, I guess of the way Trump is doing his job. Okay, and note that the sample size, I'm going to go with 1,000 because that's typical for them. Okay, it's probably not exactly 1,000, but it's probably pretty close. Is 1,000. And the proportion, the sample proportion is 0.49. I'm going to let you know we're doing things a little differently than we did for the mean and the standard deviation. For the mean and the standard deviation, if you remember, we used a Greek letter for the population standard deviation, and we used a good old-fashioned letter for the sample, right? S for the sample, sigma for the population standard deviation. Same thing, we did an X bar for the mean for the sample and a mu for the mean for the population. We're not going to do that for proportions. Any guess why? And the hint is, when I taught at Sonoma State 25 years ago, we did. And it was a disaster, not just because I did it, just that everyone was doing it. So everyone stopped doing it. And you know why? Okay, what's the Greek letter for P? That you all know. I know you don't speak Greek, but that one you know. It's the only Greek letter that everybody really knows. Not seeing y'all jump in the chat box. Greek letter for P is pi. And pi is really confusing to use as a variable. So we don't use it. Okay, so if you're wondering why I'm not going to be using Greek letters for population portion, that's the reason, is that we'd have to call it pi, and everyone thought that was 3.14, and you get a whole disaster. So confusing. So instead, what we're going to do is we're going to say the sample proportion is, and let me put it as an equation. Is like that. Anyone know how to read that? And the hint is, you read it just like it looks. Yeah, P hat, not pi hat, by the way. It's P hat. Yeah, P hat, because there's a hat on top of the P. So everyone calls it P hat. And that's what we call it. So in this case, P hat was 0.49. Any questions on the question? Okay, so what we need now is we need actually the central limit theorem for proportions. Let's put this in red because it's important. So it turns out, let's write it out. So the mean of all possible sample proportions, I'm going to call that mu sub P hat. And the good news is it's easy. It's P. Okay. P, by the way, is the population proportion. And sigma sub P hat, that's not so easy, by the way. Is equal to the square root of the fraction P times 1 minus P. And sometimes you'll call 1 minus PQ, by the way. It's just a letter they use sometimes. All over N. So that's a central limit theorem for proportions, but there's a little more to it. Do you remember there was a little more to the central limit theorem for means? What else did we have besides the two formulas? And it was really important. The hint is it's the last thing I asked on the quiz. Maybe you know? Does it apply? I'm looking for a very special word. Think of word. Starts with an N. normal. The sampling distribution is approximately normal. When, and this gets really confusing for everyone. I'm not sure why, but it is. So you need to get this down. When n times p is greater than 5 and n times 1 minus p, also called q, by the way, is greater than 5. And what those are is the expected number of yeses and the expected number of no's must be greater than 5. Right? If you take the number of people who you asked times the proportion of yeses, that's the number of yeses. And if you take the number of people times 1 minus a proportion of yeses, that's the number of no's. Okay, so I will let you know I always ask questions where you have to know what circumstance you're in. Are you in the proportion circumstance or are you in the means or total circumstance? If you're in the proportion circumstance, what number do I do not want to see written on your paper? Okay, possibly not 30, but the one that everyone gets confused is, not 0, is not 30. It's 5, okay? So you have to have the number, the NP and n times 1 minus p greater than 5. Do not say that n is greater than 30, so therefore we can, we don't have to assume normality. Does that make sense? Okay, I do want to let you know the number 30 and the number 5 are somewhat standard, but they're not perfect. And what I've learned is I'm just going with it. We're going to stick to it in this class. In the real world, some people use 10 instead of 5. Just let you know that. But it gets too complicated if we start getting into those details. So since this is an elementary statistics class, we're going to stick to 30 for a quantitative study and 5 for a yes/no kind of variable. Any questions at all on that? Okay, so now we're ready to answer the question because now we have the central limit theorem. So let's go answer the question. And that is, what is the probability that the majority of Americans approve of the way Trump is doing his job? So to do that, what we need to do is we need to start out with the distribution. Okay, we've seen that before. It's always going to be this order. And now it's not going to be X. It's not going to be X bar. What is it going to be? What letter? The hint is I spent some time just now talking about that letter. Yeah, p hat. Okay, so the first thing is it's p hat, not X or X bar. So p hat, and then I can go tilde, and then n. And now what I'm going to do is I'm going to plug in our formulas. Well, our guess for our proportion is, if we want to find out if the majority of Americans approve, if the majority of Americans approve, what percent is that? What percent marks the majority? Not 0.51, yeah, 50%, okay, or 0.50. Okay, I'm going to give you an example of where that's really important to be personal. Okay, so let me tell you why it's personally important to me that it's not 0.51, that it's not 51% or 0.51, it's 0.50. Okay, I'm not sure if I talked to you about this, but it was, now I gotta remember, let's see, 12 and a half years ago. Okay, by the way, what were people doing 12 and a half years ago? The hint is the same thing they're gonna do in a half a year from now. What were people doing? Yeah, they were voting, okay? And I will tell you personally, 12 and a half years ago, I got 50.02% of the votes. Did I get the majority? Yes, and I was elected, okay? So I don't know if I told you I was a politician for 9 years, okay? And I won literally by 3 votes out of around 10,000. Okay, so had I needed 51%, I would have lost the election, right? So the majority is over 50%, that does not mean 51 is the big demarcation. It means 50 is the demarcation. Is that clear? And again, to me, it's really important, or I went to one. Okay, I was on the school board, by the way. So I wouldn't have been on the school board, I wouldn't have been elected. Okay, and by the way, in the second election, any guess on what percent I got? Yes. What percent of the vote? Okay, I got 96% of the vote. Okay. And I don't think the reason was because I was so amazing or anything. The real reason is I was running against a convicted criminal who was on probation for some really nasty things. I kind of wonder what those 4% were thinking, actually. So that was an easy election, but my first one was tough. Okay, so 50% is the majority demarcation. Yep, yep. Criminals are allowed to run for office. I didn't know that, but they are. I didn't know that until then. Okay, so 0.5 is our n. Our sigma sub p hat is going to be the square root. I think I need to get an equation in here. It's going to be the square root. And our p now is going to be 0.5. That's the majority. And I'm going to write it out, even though I could do this in my head. 1 minus 0.5. You probably could do that also. Divided by our sample size, which is 1,000. There we go. Any questions at all? Any questions at all on how I got my p hat distribution? Okay, now let's do the calculation. So we're going to take the square root of 0.5 times 1 minus 0.5 over 1,000. Let me write this out. Equals n parentheses 0.5 comma, and now I can't do this in my head. So we take the square root of this number. And you get 0.01581. How about 0.0158? Any questions so far? All right, we're just about there. Okay, now we want, well, what would the probability be to get 49% or less? So what's the probability that p, and I'm just going to write hat, is less than 0.49? Given what we've got here. And let me write it down, 0.5, 0.0158, and less than 0.49. Now we go to our calculator. That calculator. So low, I'll just call it 0, it doesn't matter, 0.49. The mean is 0.5. The standard deviation is 0.0158. And there's our probability. Okay, about 26% chance. I'm going to go 2 decimals because that's all anyone cares about. I don't think I've ever seen the news do more than a decimal percent. So that was again, where was I? 0.26. So there is a 26% chance. By the way, is that like very, very low, or is that not so low? What do you think? Yeah, it's not so low. In fact, I don't know if you remember, I mentioned it, I think last week. What's kind of the delimiter on when the chance is considered to be low, considered to be very low? What is that, like wall? Do you know what percent? So again, I mentioned about a week ago, I think. Yeah, 5%. Okay, so this is definitely not even in the ballpark of 5%. Any questions on that? So this is going to come up in a huge way later in the class. But when you get a number that's like pretty much above 5%, what we say, and you might have even heard these words before, is that it's statistically insignificant. Have you heard those words before? Yeah, so that's actually, believe it or not, the most important thing in the entire class. Not today, but we're going to spend many weeks on, last 4 weeks of the class, almost like close to half the class, maybe 5 weeks of the class on statistical significance. Okay, so this is not statistically significant. There's not a big chance. I do want to mention something, and this is kind of important, is that what this is saying, that what this sampling distribution is approximately normal is saying, is that the normal distribution is a good approximation of what distribution? What's the distribution we had earlier in this course that has to do with the yes/no question? It's a good review. Can you remember? I don't see it. It starts with a B. That's a hint. Yeah, binomial distribution. The normal distribution is a good approximation of the binomial distribution as long as NP and NQ are both bigger than 5. Okay. Just a note, since I programmed, I might as well show it to you. If we go, let's see, this one. Yeah. Where are we? Takes a second to load up. Somewhere in here. I thought it was this one. right, sorry about that. Might be on the wrong page. Could also get it from here. I put it in the book. I just can't remember exactly which section, but it's in the book. But that one. So this shows you how close the binomial distribution is from the normal distribution. And what you can do is you can choose what your n is and what your p is. So this is n equals 50 and p is 0.5. If p is 0.06, you'll notice it's not as good a, the normal distribution is not as good a fit to the binomial, kind of off a bit. You see that? On the other hand, if we increase our n, now the normal is actually getting to be a better fit. Okay, and if I look at this, it's almost perfect over here. So the better, the higher n is, and the closer p is to 0.5, the better fit the normal distribution is to the binomial distribution. Any questions on that? Okay, but we're done with binomial distribution. We're not going to talk about it other than saying that we're going to use the normal distribution if we have a large enough sample size, and that'll be good enough for us. Got it? Any questions at all on any of these examples? Any questions? Okay, I might as well, I'm going to get a little ahead, which is a good thing because I can. And draw a picture. Ooh, that was bad. That's a better normal distribution. Let's suppose you have a normal distribution. And what we want is, we want to say 95% falls in between. Not doing it. Let's try again. So that's usually what we're interested in. We want to say 95% falls in this area. And what we're often interested in is, what are these two values? So let's just give them some letters. So we want to find what are A and B so that 95% is within. And what's going to happen to do that, what you need to do is you need to understand a few things. We need to say, well, it depends on the mean and the standard deviation. Does that make sense? But we now have formulas to find the mean and find the standard deviation using the central limit theorem. So let's go back. So here's our wonderful picture. But the mean and standard deviation are going to be found for proportions like that. For sums, that's how you find the mean and standard deviation. And then for averages, that's how you find the mean and standard deviation. That's the standard deviation. And then the mean was just mu. You remember that? So what's coming up is we're gonna have a picture like that. And we're gonna have to say, well, what is the mean? What are A and B if we know that this has to be 95%? Any questions on that idea? Well, how do you do that? If the middle is 95%, then what we're going to have to do is we're going to have to find the high and the low, and we're going to use symmetry. Okay, so that means, for example, if the middle is 95%, how much is this left area? How much is this left area over here if the middle is 95%? So we've talked about this before, but I want to bring it up again because it's going to be big on next Tuesday. What percent? So if the middle is 95%, how much is the left area? What percent is it? I don't see y'all jumping in. Good, good, 0.025. So if there's 95% inside, there's 5% outside. Half of that 5% is the left, and that's 2.5% or 0.025. So then when you go to your calculator, there we go. Oh, that's right, I got rid of the calculator. When we go to the calculator, let me get there. We're going to have our P is 0.025. Our low is going to be negative 9999. Except the negative didn't happen. There we go. Any questions on that so far? The high is what we don't know, and the mean and the standard deviation are going to come from the central limit theorem. So that the mean might be mu, it might be mu times n, or it might be p. The standard deviation is going to be either it's going to be just sigma, it could be sigma over the square root of n, it could be sigma times the square root of n, or it could be the square root of pq over n, because we had all those formulas. So use a formula, put in the mean, the standard deviation, and you can get your high. Any questions on that? And that'll help us find that lower bound. Okay. You could also get the upper bound, that right side, by saying that the low is what you don't know, the high is positive 99999, and then the probability is 0.025. And you put in the mean and standard deviation, and that'll give you your right-hand side. Any questions on that? So that's where it's coming. Figured I might as well introduce what's about to come next week. And what we're going to call that, and again, this is going to happen next week, is a confidence interval. So we're going to spend a whole week just on that idea, but it's used in a big way. So that's the plan. And we're about finished up. So let me go ahead and stop the share. And I'm going to ask if there's any questions. I think I'm going to even stop the recording.